Hello everyone. Today we're going to solve LeetCode 3-sum problem. So we're given an integer array nums. We need to return all the triplets such that they all sum up to 0, knowing that we cannot use duplicate indices in each tuple, right? So how we're going to approach this is actually this is very similar to two-sum problem. So first thing we're going to do is we're going to sort the array, right? So yeah, and then we're going to pick an index, fix that index, and use a left pointer and a right pointer, right? And if the sum of those three, like the fixed index and the left pointer and the right pointer, equals 0, we're just going to increment the left pointer, decrement the right pointer, and go on like that. So it's basically like based on like two-sum LeetCode problem, and then we're going to do the same thing for the second index. We're going to fix that, and then we're going to take the rest of the array, take a left pointer and right pointer, and do the same thing, right? But since the problem is we need to only include unique tuples, so we can actually put all those tuples in a hash set, so we don't get duplicates, right? So first thing we're going to do, we're going to check if array equals null. Then we're going to return a new array list, an empty array list, right? And we would also sort the array, as we said, arrays.sort nums, right? And then we're going to have to use a hash set for that, for eliminating the duplicate tuples. So set list of integer results equal new hash set, right? So we're going to traverse the array, right, as we said. I less than nums.length minus 2, because as we said, we need like we basically need at least 3 elements, so we can't go that far. We can only go that far, right? So that's why n minus 2. And yeah, increment I. Then we're going to use left pointer equals num I plus 1, right? And right is going to be equal to nums.length minus 1. And then we're going to do pretty much the same thing as two-sum problem. So while left is less than right, we're going to calculate our sum equals nums of I plus nums of left plus nums of right. If sum equals 0, that's when we have to add that to the hash set, right? So results dot add arrays as list, and then we're going to add all of those 3 indices, nums of I, nums of left, nums of right. Yeah, so that's our first conditional statement. But if else if the sum is less than 0, sum is less than 0, and this is our last conditional. If the sum is less than 0, then that means the sum is too little, meaning we have to increment the left pointer, right? Also forgot to, here I forgot to increment the left pointer and to decrement the right pointer, right? And in the last case, if the sum is bigger than 0, that means the sum is too big, meaning we have to decrement the right pointer, right? Right, minus minus. Yeah. And last thing we have to do is to return this hash set, right? So yeah, so return new array list, and then we're gonna pass this hash set into the constructor of this array list. So yeah, let's see if this works. So some simple mistakes here. Forgot the space here, forgot this end. Let's see if that works. If nums equal num. I think that's it, hopefully. This is called result, not results. Yeah, that works. Let's submit. So for the time complexity, we know here at most we're going to do n-1 operations, here n operations, n-2 operations I mean, and here n-3, then n-4. So at most this is going to sum up to n times n-1 over 2, which gives us n squared time complexity, right? And for the space complexity, it's in order of big O of n, right? So yeah, that's it. See you in the next one.